Now the lymphocytes, they can break themselves down in a couple of different types of categories because when they're first made, they are not a mature cell. They sort of go and subspecialize. If they go away to college, go away to school, instead of being in the bone marrow, they leave the bone marrow and they go to the thymus. Do you remember where the thymus is located? In the thoracic cavity, behind the sternum, behind the sternal bones. That's the thymus. Remember, this is what is large as a child and shrinks down as you get older? Okay. If those lymphocytes go to the thymus and they get their secondary education there, then we call them T cells. T for thymus. Should make sense, right? And I have some examples of some of the T cells here. Helper T cell, also known as a CD4 cell. Suppressor T cell, also known as a CD8 cell. Cytotoxic T cell. Natural killer cell, or an NK cell. The one that's going to be important to you, this group, are the helper T cells, the CD4 cells. This cell is important to you because this is the cell that is targeted by the HIV virus. This specifically is the cell that gets infected with the human immunodeficiency virus. This is his target. If that lymphocyte stays in the bone marrow rather than going away for his education, if he stays local, stays in the bone marrow, and he matures in the bone marrow, then we call him a B cell. B for bone marrow. Makes sense, right? B for bone marrow. Now, the B cell does a couple of different jobs. One of the ones we're going to talk about is an important one. When he gets activated by another cell, he changes into what's called a plasma cell. And then that plasma cell makes antibodies, what we call immunoglobulins. So we'll talk about those in just a little bit. So when the B cell gets activated, he turns into a plasma cell, and as a plasma cell, he makes antibodies, or immunoglobulins. And we'll talk about those in just a little bit. Because we are still not done talking about the A granulocytes. There is still one more type of A granulocyte. Lymphocytes was one, this is the second type. They are called monocytes. Monocytes are large. They have a large kidney bean-shaped nucleus. They become what's called a macrophage, very large phagocyte. And then they become tissue specific. In other words, they'll go to the skin, or to the lungs, or to the spleen. And that kind of makes sense, because now they're probably going to stay in their territory, and they're going to know their area better than anyone else. So if something happens in that area, you'll be able to recognize it quickly. Now, this is a nice model of the white blood cells and some of the red blood cells. When you look at a blood smear on a slide under a microscope, you're not going to see something that looks like this, because this has a representation of all these different types of blood cells at once. What you'd see is the whole thing would be covered with red blood cells, which are these. Notice they have no nucleus. Notice the size difference as well between the red blood cells and white blood cells. But the whole thing would be covered pretty much with red blood cells, and you might see one of these and maybe one of these. So if you might see one of these, what type of cell do you think this would be? Which one? You got it. Which one though? Which one? Which is the most common? The neutrophil. The neutrophil is the most common cell, right? The most common white blood cell. It makes up to 60, even up to 65% of all white blood cells. So chances are, this is the one you're going to see. Also, look at, you can kind of see the granules in here, but look at the lobes of the nucleus. A lot of different shapes, a lot of different lobes. Polymorphonucleated leukocyte. So you'll probably see one of these. You might even see one of these. Notice this is an agranulocyte. Does not have the granules. And it's the smallest of white blood cells. So this would represent a lymphocyte. What do you think this one is? What's the name of this one? Why? Because it's the largest of the white blood cells, and it has a big kidney bean-shaped nucleus. So just by looking at this, you should really easily be able to pick out a couple of these very fast. Red blood cells, they're red. That should make it easy. Neutrophil, polymorphonucleated leukocyte, because it has a lot of lobes to it. Lymphocyte, smallest of the white blood cells. It's still bigger than the red blood cells, but it's smallest of the white blood cells. And then this very large monocyte right here, which is going to become a macrophage. You'll even see these little blue specks here, here, here. Those are called thrombocytes. We'll talk about those in a little bit. We like to call them platelets. So you can see some of the size difference here in these cells and cell parts or cell particles. Notice all the white blood cells have nucleus or nuclei, plural. So what's that mean? What will we find? DNA. Remember, if it has a nucleus, it's going to have DNA. Red blood cells. Do you see any nuclei in the red blood cells? No. What does that mean for these mature red blood cells? No nucleus. No DNA, right? Excellent. All right. On the top of page 77, the next page there is mast cells. Mast cells. Mast cells. Mast cells release histamine in the tissue. Which causes a vascular permeability. Now you're going to say, wait a minute, I thought it was the basophil that released histamine that causes the vascular permeability. Well, you're right. They both do. However, where were the basophils located? In the blood. The basophils were located in the blood. Mast cells are located in the tissue. So when we see that problem occur, right here, that sends out the distress call, the 911, and we have a basophil that's going to release But the thing is, this wall is not just one wall, it's made up of a couple of layers. So what we have to do is we have to have somebody open the door from this side, and we have to have somebody open the door from the outside. One's opening the outside door, the other's opening the inside door. And that's what the mast cells do. They release histamine to help open the doorway on this side. That way, the basophils will ensure they're releasing histamine in the right area, and now those cells that are in the blood can move from the blood and go to that area, like the neutrophils. Make sense?